Hey everybody, welcome to the Chapter 5 Python programming presentation. Like last time, there's an agenda presentation where I'm going to cover most of the key terms that we encountered throughout the chapter, but I'm only going to really discuss the bolded terms I show. Feel free to pause at any point and rewind to view any definitions or visuals that I provided. Introduction to loop. This whole slide is pretty important because the rest of the presentation and the rest of the chapter builds off of this concept. So let's talk about it. A loop is basically a control structure that allows the execution of a block of code to happen multiple times with varying conditions. An iteration is a single execution of the loop body. An iterable is an object that is capable of returning its members one at a time, and the loop body is the block of code that executes during each iteration. This is a visual that explains the concept of a loop. The program starts and it is fed into the loop statement, which checks is that the last variable in sequence. If it is true, then it goes into the statement body of the loop and exits the loop. If it is not true, it'll go back and try the next loop variable. Types of loop. This whole slide is also pretty important because it's using the basics we discussed earlier to actually apply it to the code that we'll be seeing soon. While loops are code blocks that repeat as long as a given condition is true. For loops iterate over a sequence like a list, string, or a range. While loops and for loop correspondence. A while loop can often be rewritten as a for loop and vice versa. Nested loops are a loop inside of another loop, like we saw with if statements. And an outer and inner loop are quite literally how they sound. The outer loop controls how many times the inner loop will run. This is a list of shorthand operators to make looping easier to set up. You might have already seen these, but these are used very often when it comes to iteration and referencing different sorts of loop variables. So it's very important to get used to using them. Loop control mechanisms. A sentinel value is a special value used to signal when a loop should stop running. A break statement, break, is a statement that exits the loop immediately after it's run. A continue statement skips the current iteration and moves to the next iteration of that loop. In the Xilabs activity 5.16.1, output range with increment of 5, it states that we should write a program whose input is two integers, output the first integer and the subsequent increments of 5 as long as the value is less than or equal to the second integer. It provides an example where if the input is negative 15 and 10, the output will be negative 15 space negative 10, negative 5, and so on. It also provides the second case where the second integer is less than the first, where you have the inputs 20 and 5, and the output is said that second integer can't be less than the first. On the left half of the screen, you'll see the code that I provided for this particular question. I stated that first num is an integer input and second num is an integer input. I stated that if second num is less than first num, then it would print second integer can't be less than the first. Otherwise, if second num is greater than first num, it would say that the current value equals the first num, in which the current value is our loop variable. Then I provided a while loop where if current value is less than or equal to second num, it would print the current value, and then it would provide a space directly lateral to that, and then it would increment current value by 5. This while loop would repeat until the while loop is no longer true, in which it would provide a print statement at the bottom, and then end the program. I also provided a section to the right where I made a diagram so that people that are more visual learners like I am could see the sequencing of the events. I showed at the top where the program starts, it's fed into those two int inputs, first num and second num. Then it's given to an if statement, which splits branches into true and false sections. The true section will just end the program, And then the false section, which is the else branch, would allow for the while loop to iterate until it is no longer true, in which it would print that space at the end and then end the program. Hopefully the diagram is useful for understanding this concept a little bit better. I thought that this was a good example of it. Aside from the example, here are some useful loop functions and techniques. Range, which is very typically seen in for loops, generates a sequence of numbers. Reversed is a function that iterates over a sequence in reverse order. And enumerate retrieves both the index and value when looping over an iterable. Here are some best practices and additional concepts from the chapter. Randint generates a random integer often used in loops. We discussed this earlier, so I'm not really going to go into it. And then the functions shown on the line just after that are functions that convert characters to their Unicode values and vice versa. This is pretty useful for character manipulation in loops. And unpacking process is a process where it splits multiple values from an iterable into separate variables. Thank you for watching the video. Hopefully this benefited you and helped better understand the concepts of loops from chapter 5. Have a good day. Thank you.